All right, problem number 7. Determine the equation of the tangent line, normal line. Once again, I just did the tangent line, but we can look at normal also. We have a function f of x is equal to the tangent of 6x, and we're looking at the value at x equals pi over 6. So we have to find the equation of the tangent line, which means we need to find slope and point of tangency. So our point of tangency is going to be pi over 6, and then the tangent of 6 times pi over 6. Well, if I take 6 times pi over 6, this is the tangent of pi. And pi is a degree measure of what? 180. So in a degree mode, I can take the tangent of 180. In a radian mode, I can take the tangent of pi. Does not matter which one you do. You just need to make sure you're in the correct mode for what you're dealing with here. If you take the tangent of pi, you need to make sure you're in radian mode. Either case, you should get a value of 0. So our point of tangency is pi over 6, comma 0. Then we have to find our slope, which is our derivative. Well, the derivative of tangent is what? Secant squared. So we have secant squared of 6x. But then we have to multiply it by chain rule, the value of 6. So we have 6 times secant squared of 6x. So if we look at 6x and trying to find the secant of this, we have to find our derivative at pi over 6, which is 6 times and I'm just writing it in a different form so it's a little bit easier for us to understand. We have 6 times the secant of 6 times 6x, all quantity squared. So we're looking at 6 times the secant of pi squared. Well, we don't have a secant button on our calculator, but this is also the secant of pi is 1 over the cosine of pi, which means that is the cosine of 180 degrees. The cosine of 180 degrees is, or cosine of pi if you're in the radian mode, -1. So this is 1 over -1 or -1. So we have 6 times -1 squared, which is a value of 6. So if I look at my equation, I have a slope of 6, x minus our x value, which is pi over 6, is equal to y minus our y value, which is a value of 0. So if I distribute through, I'm left with 6x minus pi is equal to y. Now if we look at the normal line, this is tangent. This is tangent. If I look at normal, our slope then just turns into the opposite reciprocal. So we have negative 1/6. So we have negative 1/6 times x minus pi over 6 is equal to y minus 0. So we'd have y is equal to negative 1/6 x plus pi over 36. I'm going to distribute my negative 6 through, or negative 1/6 through. Or if you put it in the form, standard form, we would have x plus 6y is equal to negative pi over 6. Either form, once again, I'll accept either form. Other questions? The first number 7. The secant of 2x we have to find f of x equal to secant of 2x. We have to find the value of the derivative at pi over 6. So we have to take a look at the derivative of the secant. The derivative of secant is what? Secant times tangent. Secant tangent. So we have secant of 2x times the tangent of 2x times the derivative of what's inside, which is a value of 2. So we have 2 times secant 2x times the tangent of 2x. Now we have to calculate the value at pi over 6. So substituting in pi over 6, we have 2 times the secant of 2 times pi over 6 times the tangent of 2 times pi over 6. Well, if I multiply 2 times pi over 6, that gives me pi over 3. So if I take a look at my 30-60 right triangle, maybe. Throwing our values in, we have a value of 1 across the hypotenuse, 2, square root of 3. Pi over 3 is what degree measure? 60. So this is 60. So we have 2 times the secant. The secant's reciprocal to cosine. So if I look at 60 degrees and I go reciprocal of cosine, I have 2 over 1 times the tangent of 60, which is opposite over adjacent, which is square root of 3 over 1. So we have 2 times 2, which is 4, times square root of 3, or square root of 3. Other questions? Other questions? we have to remember is function and derivative. Function sine, derivative is cosine. Function is cosine. We have negative sine of x. If we have the secant, we have secant tangent. If we have the cosecant, we have negative cosecant, cotangent x. And then if we have tangent of x, we have secant squared of x. And if we have cotangent of x, we have negative cosecant squared of x. All your co-functions over here, the negatives over here. And it's just one of those things that, as we remember, e to the x is e to the x, the derivative of e to the x is e to the x. If we have a x to the n, we have a times n x to the n minus 1 power. Just the properties that we have learned in regards to derivatives, we continue to add to them. And then you have your chain rule that goes along with that. Anything else? Okay.
Yeah.
Bite your finger. You will be asked on your next test. You'll be asked to prove one of those, as we proved all of them in class yesterday. You'll be asked to prove one of them. So if I say prove the tangent, the derivative of the tangent of x, you just can't write secant squared of x. Okay, you have to go through the proof by using your quotient rule and go through the proof of what is the derivative of the tangent or the cotangent or the secant or the cosecant. Okay, so you'll be asked to prove one of those on your next test. Okay, with derivatives, with these, you just have to continue to practice. The art of the chain rule, the art of the trig functions, because it's just the process is repetitive time and time again, but it's one of those things where there's little nuances that you have to continue to worry about and make sure you take care of, like especially with the quotient rule, being able to cancel things out of all the terms when you go through your quotient rule. But dealing with square roots, how you deal with square roots and work through them, or if you have a negative exponent, then problem number 2, you can write that as, you can use quotient rule or you can use negative exponents there. There's just different things that you have to worry about. So today we'll go through some more practice with this. The rest of the time will be given to you. Tomorrow we'll get into implicit differentiation, and then we'll work through logarithms on Friday. Yeah. We just get to have more fun. It even gets more funner.
Is it fun for you or fun for us?
Yeah. Yeah, it is. Exactly what you said. Solutions are posted. I will also print you all some. The rest of the time is yours.